Good morning, students. I hope that you will be happy at home. Now, a question was asked me to revise function, the part of first chapter, but the chapter is well known to you, that is relation and function. I am focusing on some important points of the function, and I want that you will, after reading this, can solve the question by the method given in this. We have already discussed all the things of function, but keep in mind what a function is. Function A function is a relation between two sets A to B. It is a relation and it is called function if every element of set A has one and only one image in set B. Image means association with the element of set B. In other words, a function is a relation from a non-empty set A to a non-empty set B such that the domain of F, that is A, and no two distinct ordered pairs in F have the same first element. We take an example. Let A is equal to a set containing 3 elements 1, 2, 3, and B is another set containing element 4, 5, 6, 7. Now, if F is some kind of relation in which the pairs are 1, 4, 1 is associated with 4, 2 is associated with 5, and 3 is associated with 6. Be a function from A to B. Why? Because every element of set A are associated uniquely with the element of set B, as one of set A is associated with element 4 of set B and not others. Similarly, 2 is associated with 5 and not others. In this manner, we can say this is the function. Now there are so many functions, but here two types of functions are mainly discussed, and combining these two we get another type of function also. The function is one to one, that is called injective function. A function f such that A to B is said to be one function if every element of set A has distinct images in set B. That is, we take any two elements of set A, x1 and x2 belongs to A, such that their images are equal, means fx1 is equal to fx2, and after putting the value we get the result x1 is equal to x2, means if the images of two distinct elements are equal, then those two distinct elements are not distinct, those are also equal. Then we say that f is 1 1. This is the procedure, and you have to keep in your mind that if proving injective function, we will take two elements of first set and such that fx1 is equal to fx2, and putting the value of relation, and we get x1 is equal to x2, then we say f is 1 1. Now an example is there, a function f such that n to n defined by as fx is equal to x square is 1 1. How? We take any two elements 1 and 2 of set n, because it is defining n to n. Here the element will be taken from first n. So f1 will be equal to how much? Fx is x square, then f1 is f1 square, that is 1, and similarly f2 will be 2 square, that is 4. Here 1 and 2 taken elements are not equal, and we see that their images f1 and f2 are also not equal. That means no two distinct natural numbers square are equal, so we say that function is 1 1. Similarly, we can take another example, f such that z to z, z means the set of integers, z to z defined as fx is equal to x square is not 1 1, as I am taking two elements -1 and 1 which are belonging to z, which are integers. Now according to definition, f minus 1 will be equal to -1 whole square, that is equal to 1. f1 will be equal to 1 square, that is also 1. Hence we see that f minus 1 and f1 both are equal, having value 1 1 each, but images are equal, but -1 is not equal to 1, so it means function is not 1 1. Their images are equal but elements are not equal, so it is not 1 1. Now we take onto function, or that is called surjective function. A function f such that x to y is said to be onto or surjective if every element of y is the image of some element of x under f, under relation, that is called under f. That means we go through the step, for every element y belonging to y, there exists an element x in x such that fx is equal to y. What does it mean? It means we take any one element y of second set. Second set is y, capital Y, and thus we get element x in first set such that fx is equal to y. This is the procedure. Now example, a function f such that n to n defined as fx is equal to x is onto function. How will you define? You take any two values of n, that is 1, fx is x, so f1 is 1, and any other element 2, f2 is again 2. So we see that every natural number is distinct, so their images are also distinct. Means each natural number is having different images in second set. So we see that this is onto. But if we take a function f such that n to n defined as fx is equal to x square. So what does we take any two elements, f1 is taken, 1 is taken, f1 is the value, that will be 1 square, that we get 1, 2 is another value, we take f2 is 2 square, that is 4. Thus we see that element 1 of first set is associated element 1 of second set, and element of 2 of first set is associated with element of second set 4, and thus so on. But we see that in second set there is 2 and 3 are such elements which are not the square of any element of first set. So 2 and 3 etc. are not images of any element of first set and in second set n. So f is not onto. It means there are some elements in second set which are not associated with the element of first set. So we can say f is not onto. Now remember some steps for showing a function f a to b is 1 1. The step is take any two element x1 and x2 belonging to set first set A. You have to take two elements from the domain of the set such that fx1 is equal to fx2, which implies x1 is equal to x2. Means you are taking two elements of first set and such that their images are equal, and then you get the result x1 and x2 are also equal, means those elements are same. Thus we can say the function is 1 1. Now step to show function f such that a to b is onto. That means you have to show onto function. What will you do? You take any one element of set B. B means second set. In case of 1 1 we take two elements of set first set, and in case of onto we take any element of second set. Take any element y of second set B such that y is equal to fx. Y is equal to fx, and put the value of fx. You will express x in terms of y, and if you put any value of y means the value from second set, then its value x must have a value in first set also. This is the procedure. A question is there. Show that the natural number f such that n to n defined by fx is equal to 2x is 1 1 but not onto. Its solution, taking we have to show first function is 1 1, f such that n to n is 1 1. What will you do? You take any two element x1 x2 belonging to n. N means first means first set. Both n are same, but we are taking the element from first set 1, such that fx1 is equal to fx2. Now fx is 2x, so fx1 became 2x1, fx is 2x, so fx2 also becomes 2x2. It means 2x1 and 2x2 are equal, cancel out 2, we get x1 is equal to x2. We get the result, x1 is x2, so f is 1, 1. Now to show f is not onto, how will you show? You take any one element of second set, second n, such that y is equal to fx. Now put the value of fx, we get y is equal to 2x, and find the value of x, we get y upon 2. X is equal to y upon 2. Suppose now it is not always a natural number. Why? Suppose I am taking y is equal to 3 from second set, and then x will become 3 by 2, that is 1.5, which is not a natural number So this number is not associated with the element of first set. Hence we can say that f is not onto. There is another example. Let A is the set containing 3 elements 1, 2, 3, and B is another set containing element 4, 5, 6, 7. And let f is any relation or any function is equal to the containing elements 1, 4, 2, 5, 3, 6. So it is a function. Why? How will you show that it is a function? We must see that in function, first elements of each pair are not identical, and every element of first set must be there in each pair. So here we see that f such that a to b is equal to f1. 1 is associated with 4, so f1 is 4. 2 is associated with 5, so f2 is 5. So 3 is associated with 6, so f3 is 6. So every element 1, 2, 3 of set A has distinct images in set B. So we can say that this is 1, 1 function. Now combining these, we get another type of function, that is bijective function. Bijective function means the function which is 1, 1 as well as onto, which is injective as well as surjective. So to prove a function is bijective, you have to show function is 1, 1 and also show the function is onto. There an example, a function f such that n to n defined as fx is x is onto. How will you say onto? If we take element from set, f1 is equal to 1, f2 is equal to 2, as fx is x. So we are taking natural numbers 1, 2, 3 like this, and their images, f1 will be 1, f2 is 2, etc. It means each natural number has different images. So it means f is 1, 1, and also we see that every element of second set n has its pre-image in first set. So f is also onto. Thus we see that function is bijective. Now there is the result, a bijective function is invertible also. That means it has inverse. If a function f such that a to b is bijective function, then there exists a function f inverse such that b to a. F is a to b bijective, then its inverse will be b to a. That is if y is equal to fx, we take, this implies y is equal to f inverse, x is equal to f inverse y. Now I am taking an example. Show that the function f such that r to r defined by fx is equal to 2x plus 9 is bijective. Also find f inverse. First we have to find it is 1 1. To show f such that r to r is 1 1, we take any two element x1 and x2 from set R, that is first set R. So such that their images fx1 is equal to fx2. That means 2x1 plus 9 is equal to 2x2 plus 9. As fx is 2x plus 9, so fx1 will be 2x1 plus 9 and fx2 will be 2x2 plus 9. Cancel out 9, we get 2x1 is 2x2, cancel out 2, we get x1 is equal to x2. Hence we see that function is 1 1 or injective. Now to show the function is onto means surjective, what will you do? You take an element from second set. Let y belongs to second set such that y is equal to fx. That means y is equal to 2x plus 9, as the value of fx is 2x plus 9, and after solving we get the result x. We have to explain x in terms of y. That means x is equal to y minus 9 upon 2, and y is a real number, so y minus 9 is also real and y minus 9 upon 2 is also real. It means x has real value in first set, so we can say f is onto or surjective. Hence f is 1 1 and onto function, so f is a bijective function. Now how will you find f inverse? We have y is equal to fx, that means x is equal to f inverse y. But from above we get x is equal to y minus 9 upon 2. So x is equal to y minus 9 upon 2 and x is also f inverse y. That means f inverse y is equal to y minus 9 upon 2. Or simply we can replace y by x. So we can write f inverse x is equal to x minus 9 all upon 2. Thus we can find inverse of function, and similar way we can solve the question from your exercise 1.3, 4, 5, 6, 7, 8, 9. Do accordingly, and you see in this chapter binary operation which is not in your syllabus, and composition is also in your syllabus, which we have already discussed some points. Solve these all. Thank you. That's all.